So question 2. Well, we're given a bit of information. We're told that we've got 8 weeks, and we're told product moment correlation coefficient that's been calculated, and it's between sales figures and average weekly temperature. So we need to write down our hypotheses. So our hypotheses are quite simple. So we got our null hypotheses. That's where there's nothing going on as such. So we would just say that we've got a correlation is equal to 0. And then the alternative hypothesis is that we expect there to be a negative correlation. That's what we're looking for. So therefore, we just say correlation looking to be less than 0. Now it says about looking at the 5% level over 8 weeks. So you need to write down the critical value. And the critical value, if you just use your tables, right, just go and look in your exam tables. So the critical value is going to be 0.6215, but it's a minus, isn't it? Now, as our value is less than this, because it's negative, if we're looking at a positive one, then obviously we'd be saying more than. So as it's less than this figure, 1.5, then we can accept the alternative hypotheses. Now I'd put that into real words as well. I'd say, look, you know, there seems to be a negative correlation between sales figures and the average weekly temperature, right? Add that in as well. Right, now part B, suggest a possible reason for this correlation. Well, remember it's a seaside town, so therefore warmer, less likely to shop. There we go. I don't know about you, when it's hot, I don't really want to go shopping. Go to the beach. Right, and part C. It says, well, Tessa suggests that a linear regression model could be used to model these data. State given a reason whether or not the correlation coefficient is consistent with this. Well, yes. Okay, and we need to give a reason, right, about why it's going to back up. Well, linear, now, a lot of people actually forget about this. They just go in and just start doing linear regression. But actually, the first thing you should be doing is you should be doing a correlation test. And linear regression is only really valid. Linear regression is only really valid if there is a correlation, which there is in this case. And then part D. State given a reason which variable would be the explanatory variable. Well, it's temperature, okay? Now, why? Well, because the other one, the sales, depends on the temperature. Not that you've got any control over the temperature, but sales depends on temperature. So that's why that one. And then part E. Tessa calculated a linear regression equation as this here, right? It looks horrible. It says, give an interpretation of the gradient of the regression equation. Well, we're talking about this bit here, all right? Let's make sense of that. So it's a minus figure, isn't it? So if I were to draw it on a graph, right? Imagine I've got my scatter graph, I've got something like that, haven't we? So that means as the temperature increases, so you want something like this. So for every increase in 1 degree, sales drop by £171, because that's the figure that's there.